Okay, so in the previous video, we talked about using p-values for hypothesis testing, which is fine, but another method we can use are rejection regions. Now, it doesn't matter which method you use, you'll come up with the same conclusion. Personally, I'm a little partial to rejection regions. I think it's a little more visual way of doing hypothesis testing. So what is this method? So we use the alpha value to represent an area in the tails. Now, these descriptions here are a little convoluted here. Alpha is the area if it's left-tailed. If it's right-tailed, we need to do 1 minus. And if it's two-tailed, we have to split it 2 ways. These formulas are cumbersome. I think if you draw a picture, it's much more intuitive. Like this. So sketch the standard normal curve. Determine, again, based on the alternative hypothesis, whether it's left-tailed, right-tailed, or two-tailed. So the alpha value goes on the left over here, on the right over here, and if it's two-tailed, we'll split it 2 ways. So here we have an example. Find the critical value in rejection region for a left-tailed test with an alpha of 0.01. As usual, start with a picture. They say it's a left-tailed test. The alpha value is 0.01, which means that is the area in the tail. Now, what we need to know is the Z critical value that separates the rejection region, meaning if it's over here, we reject the null hypothesis. If it's to the right, we fail to reject the null hypothesis. Now, if this all sounds very familiar, it should. This is what we did back in chapter 5. We know the area, we need to find Z critical. So we don't use the normal CDF function, we use the inverse norm function. Now remember, when using the inverse norm function, you always have the area to the left, comma 0, comma 1 for mean and standard deviation. Okay, so if we're looking for this Z critical value right here, we know the area to the left is 0.01. So we use INV norm, 0.01, comma 0, comma 1. Which is negative 2.33. Now we get a negative, and we should, that's to be expected because it's on the left. Now, this is what separates the rejection region from the fail to reject region. All right. Now in this next example, find the critical value and rejection region for a two-tailed test with alpha equal to 0.05. So as usual, start with your picture. Two-tailed test. Alpha is 0.05. Now here we have to be careful. It's not 0.05 on the left and 0.05 on the right. We have to split it 2 ways. So if we divide by 2, the area over here is 0.025, and the area over here is 0.025. Which means this is the rejection region, The middle is fail to reject. And reject again here on the right. Now, there are two critical values here. It's Z, and because it's symmetric, these will be the same number, but the right will be positive and the left will be negative. Now, because the inverse norm function likes the area on the left, I'm going to find this number over here on the left. You could find this one, but you'd have to add the area to the left and do 1 minus in order to get the total area to the left. So we'll use 0.025, comma 0, comma 1. Negative 1.96. Negative 1.96. And that's a number that should sound very familiar from confidence intervals. Negative on the left, positive on the right. These are the Z critical values. Okay. So to conduct a hypothesis test, we calculate the test statistic Z. Then from there, using the test statistic, using the same formula that we use with p-values, we determine where it lands. So if you look at this blue area in the picture, those are the rejection regions. If your test statistic falls into the blue area, your decision is reject the null hypothesis. If your test statistic falls into the beige area, you will fail to reject the null hypothesis. So this is what we're in for. Verify that sigma is known. It'll be given to you in the problem. State the claim and hypotheses. Specify the level of significance that'll be given to you in the problem. Determine the critical value. Sketch the rejection regions. Calculate the test statistic using the same formula. Determine where the test statistic goes on the figure. So that will give you the decision. You'll interpret your conclusion in terms of the claim. So let's draw one out. So we have in this problem, employees at a construction and mining company claim that the mean salary of a company's mechanical engineers is less than that of one of its competitors, which is $88,200. A random sample of 20 of the company's engineers has a mean salary of $85,900. Assume the population standard deviation is $9,500 and follows normal distribution. At the 0.05 level, test the employee's claim. So we've got these engineers here, and they work for this construction company. They claim that the mean salary of the mechanical engineers is less than that of the competitors. And the competitor is paying $88,200. So they're claiming it's less than that. So they do a little work and they sample 20 engineers and they have a mean salary of $85,900. Now, because you gather up these 20 people, ask them their salary and compute the mean, this is the sample mean. They've told us to assume population standard deviation sigma is 9,500. So it sounds like we have everything we need here for this problem. So whether you're using p-value or rejection region, the first step is the same, which is to state the claim. All right, claim. We are talking about mean, mu. The employees claim that the mean salary is less than 88,200. Okay, state the hypotheses. The claim does not contain equality, so it goes in the null hypothesis. That's wrong. Does not contain equality, it goes in the alternative hypothesis. The null hypothesis is the complement, so it's the opposite of everything else. So it's not less than, it's greater than or equal to. Okay. With this, we have enough information to draw a picture. The alternative hypothesis is less than, which means this is a left-tailed test. This defines the rejection region. Reject on the left, fail to reject on the right. Okay, let's dissect the rest of the information from this problem. There's a sample of 20 engineers, that is our N. They have a sample mean salary of 85,900. The population standard deviation, sigma, is 9,500. The alpha value is 0.05. Okay. Now, we know where the rejection region is, but we don't know what this border is. That is the Z critical. Now, the alpha value is 0.05. That is the area in the tail. It's one-tailed, 0.05. To find the Z critical value, we can use the INV norm function. Because we're given an area on the left, we simply put in 0.05. Negative 1.645. Which makes sense. It's negative. It's on the left, and it should be. Next, we'll compute the test statistic. Now that we know what the criteria for reject or fail to reject is, let's see what we have in this case. Now we have the sample mean, population standard deviation, and sample size. Remember, population mean is assumed from the claim. So in this case, that'll be 88,200. Plug in everything else. Sample mean is 85,900 minus assumed population mean is 88,200 over 9,500 over the square root of 20. Negative 2,300 on the top. 2124.3 on the bottom. Which is negative 1.08. Now, we need to take a look at where this test statistic lands on our figure, whether it's to the left or to the right. Now be very careful because these are both negative. Negative 1.08 is greater than negative 1.645. So negative 1.08 will be somewhere over here somewhere. To the right, but not too far to the right. Which means it lands in the fail to reject region. Therefore, our decision is fail to reject the null hypothesis. For our conclusion, go to your hypothesis testing diagram. Does the original claim contain the condition of equality? Well, the claim does not contain equality, so the answer is no. Take the lower path. Do you reject the null hypothesis? No, we fail to reject the null hypothesis. So we go down. There is not sufficient sample evidence to support the claim. There's not sufficient sample evidence to support, we should say who we're talking about here, the engineer's claim that the mean, make sure you get the parameter in there, we're talking about mean, engineer salary what was the claim? They're claiming that the salary was less than 88,200 is less than $88,200. Do you have to write all that out? Yes, you do. So let's go back to the text. State the claim and the hypotheses. Again, I don't agree here. I think you should draw the picture first before you compute the test statistic. We find the critical value for Z that separates reject from fail to reject. Our test statistic was to the right of the Z critical value. So it fell into this beige area, which is our fail to reject region. So our conclusion is there's not enough evidence at the 5% level of significance to support the employee's claim that the salary is less than $88,200. Okay, that was fun. Let's try out another one. So what have we got? We have this researcher claims the mean annual cost of raising a child by married couple families is $14,050. In a random sample of married couple families, the mean cost of raising a child is $13,795. The sample consists of 500 children. Assume the population standard deviation is $2,875. At the 0.1 level, is there enough evidence to reject the claim? All right, so we have this researcher here. According to the U.S. Department of Agricultural Center for Nutrition and Policy, odd place to get data, but okay, they say that the cost is $14,050. Okay, so this researcher claims that the mean is, now that is very key here. When we say is equal to 14,050, he's saying that exactly that. Okay, we have everything we need here to do the hypothesis test. So, as usual, state the claim and the hypotheses. In this case, we're talking about mean cost to raise a child. Now, we are talking about the researcher's claim that it is equal to $14,050. Because the claim contains equality, it goes in the null hypothesis. The alternative hypothesis is the complement, it's the opposite, it's everything else, not equal to $14,050. Sketch your figure. Because the alternative is not equal to, we have a two-tailed test. So reject over here, fail to reject in the center, reject on the right. Now we need to know what the borders or boundaries of these regions are. That's going to be the z critical value. Now the alpha value in this problem is 0.1. That is not the area in the tail. That is the area in both tails. Therefore, we have to take this alpha value and split it two ways. 0.1 divided by 2 is 0.05. And now that we know the area in one tail, we can find the z critical value. Using the inverse norm function, the area to the left of this spot is 0.05, 0, 1. Negative 1.64. So the z critical value over here is negative 1.64, which means the other z critical value will be positive 1.64. And now we know what defines the rejection regions. Okay, compute the test statistic. Okay, now let's go back and dissect this problem. Let's see. In a random sample, the mean cost is $13,795. So the sample mean is 13,795. The sample consists of 500 children, so that is our sample size. Assume the population standard deviation sigma is 2,875. The alpha value this time is 0.1. Everything we need is here. Sample mean 13,795 minus, remember, population mean is assumed from the claim. So we're going to assume $14,050. Sigma is 2875. N is 500. Negative 255 on top. 128.6 on the bottom. Which is negative 1.98. Now, the test statistic is negative 1.98. We need to see where that goes on our picture. It's negative, so it'll be over here on the left side. The boundary here is negative 1.64. Negative 1.98 will be further to the left. It's going to be over here, which means it falls within the rejection region. So our decision is reject the null hypothesis. So, therefore, reject the null hypothesis. To write the conclusion, we'll go to our hypothesis testing diagram. Does the original claim contain equality? In this case, yes, it does. So we go to the right. Do you reject the null hypothesis? Yes, we did. There is sufficient evidence to warrant rejection of the claim. Sufficient. Whose claim? We should say the researcher's claim. That the mean, make sure you get the parameter in there, cost of raising a child is $14,050. And there we go, we're finished. If we look back at the text, as usual, state the claim first, and then the hypotheses. I would draw your picture first, then decide what the Z critical values are. There are two in this case since it's two-tailed. Compute the test statistic. See where the test statistic lands on your figure. Here, it's over here on the left in this blue area. That is the rejection region, so our decision is reject the null hypothesis. So there's enough evidence at this level to reject the claim that the mean cost of raising a child is $14,050. All right, and we're finished.